All right, the next section that we will learn about is inverses of functions. So if you will write that at the top of your next page in your notes, please. Okay, when you think of an inverse of something, hopefully you think of opposite. So, and that's exactly what an inverse function is. It's the opposite of what's happening. So, what we are going to do is on this left side of the notebook paper, we will have the examples, and then on the right side, we will write the steps to finding an inverse. So if you'll write that for me, please, as well as this first example of f of x equals 2x minus 2. All right, so when we look at this example of 2x minus 2, think what's the opposite of multiplying by 2 and subtracting 2 from x? Okay, so think of that when we get to the answer. We'll see if it makes sense. But for now, the first step is to replace f of x with y. So that is our first step. So that way it just looks a little bit neater. So instead of f of x, we will write y equals 2x minus 2. And then now, since inverse means opposite, then what we're going to do in step 2 is to switch x and y. And that will, in turn, give us the inverse of the original function. So you don't mess with anything with x, you just switch them exactly how they are. So instead of y, it will be x, and instead of 2x, it will be 2y minus 2. Okay, so we replace f of x with y, we switch x and y. The third step will be to solve for y, which is why we have been practicing solving equations so that this step will be a little bit easier. So for solving for y, it means we want to get y by itself. So how could we get this y all alone? Well, first we want to get rid of this subtracting 2. So let's add 2 to each side. And that will zero out over here. So when we add 2 to x, we just have x plus 2, since we cannot add those two terms together, equals the 2 times y. And then the last thing to get y by itself is to divide by 2 to each side. And when we do that, 2 divided by 2 is just 1. So then, and I'm actually going to write y on the left side, just because that's how it is usually written. So I'm just going to switch these two so it'll be y equals x plus 2 over 2. And don't simplify anything yet. The last step is to then replace y with the correct notation, which is f inverse of x. It's actually f to the negative 1 of x. So that is the correct notation for inverse. On a root, so I have to write it over here. So f inverse of x equals the x plus 2 over 2. Now, probably a lot of you would want to simplify this by dividing out the 2's. So then you might think the answer is x. but that is not the case because we are actually dividing the 2 by 2 and the x by 2. So we can't just take the 2's away and not do anything with the x. So another way to write this, since we're dividing the x by 2 and the 2 by 2, another way to write this would be f inverse of x equals x over 2 plus 2 over 2. So that's another way to think of it. And then once we split it up like that, then we could simplify the 2 over 2, since 2 divided by 2 is 1. Then our final answer could be x over 2 plus 1. Or another way is, since it's half of x, that's the same thing as multiplying x by 1/2. So either one of those would be correct. So I'm just going to circle that first one, but I just wanted to show you that that 1/2 x plus 1 is also the same thing. So those are the steps. Okay, so let's do another example. So if you'll write this example, please, f of x equals 2/5 x minus 2. So let's think. The very first step that we did is we just replaced f of x with y. So we have y equals 2/5 x minus 2. After that, we switched x and y. So switch them and leave them exactly how they are. So instead of y equals, it will be x equals, and then it will be 2/5 y minus 2. And then the third step is to solve for y. So we need to get y completely by itself. So how we can do that is we can add 2 to each side, add 2, and we get x plus 2 equals 2/5 y. And how do we get rid of this fraction in front of y? Well, the opposite of multiplying by something is to divide. And when we divide fractions, we times by the reciprocal. So what we can do is we can multiply each side by the reciprocal of 2/5. So if the reciprocal is when we flip it, so the reciprocal would be 5/2. So if we multiply 5/2 to each side, then we need to distribute the 5/2 on the left side here. So 5/2 times x is just 5/2 x plus 5/2 times 2. Remember, when you multiply fractions, you just multiply straight across. So 5 times 2 is 10. Over 2 times 1 is 2. We'll simplify that in a minute. Equals, and then on the right side here, when we multiply 5/2 to 2/5, it will be 10 over 10 times y. So now let's simplify some stuff. Excuse me. And I'm also going to switch y, so it's on the left side. So 10 over 10 is just 1. So 1 times y is y. Equals 5/2 x, cannot be simplified, so we'll just leave that as 5/2 x. And 10 over 2 simplifies to be 5, because half of 10 is 5. And that is our answer, but the very final step is to write in the correct notation, which is f inverse of x equals the 5/2 x plus 5. So, looking at the original function was multiplying x by 2/5 and subtracting 2. So the inverse of that would actually be multiplying by 5/2 and adding 5. So on this, to the right of this example on in your notes, if you will draw this XY axis for me, please. And then I would like you to also sketch this dashed line. That is actually the line of y equals x. And why that's the line y equals x is because for any point along that line, the x value and the y value would be the same thing. Now what inverses do, the inverse of a function, is actually reflected over this line. So if you take the original function, so let's look at this second example that we had, the 2/5 x minus 2. Let's graph that. And I'm sure all of you have forgotten how to draw the line, but I'm going to walk you through it. So this minus 2 is the y-intercept. So let's go down 2 on the y-axis and do a point, because that's where it will cross the y-axis. And then from there, we are going to our next point on our line, we are going to follow our slope, which is positive 2 over 5. So we are going to go up 2 and over 5. 1, 2, 3, 4, 5. And I will give you time to do that and draw your line. We could have also gone down 2 and to the left 5. And anyhow, so go ahead and draw your line. See how straight. I'm actually going to use the line tool so it will be straight. I can find it. Okay, so that is the original function that we had, the 2/5 x minus 2. And what happens now that we found the inverse of that, the inverse is the reflection of that over this line y equals x. So if we could fold our paper along this line and reflect that, what would it look like? So now let's graph the inverse. So let's graph the inverse. Remember, this is the y-intercept, this positive 5. So let's go up 5 on the y-axis, do a point. Actually, I'm going to do this in a different color. So we go up 5, and then our slope right here is this 5 over 2. I'm out of room at the top, so I'm actually going to go down 5 and right 2. So I'm going to, once I go down 5, then I'll be back at the x-axis, and then over 2, give me a point at 2, 0. And then I can also go down 5 and over 2 again if I want another point. You don't have to do that. And then let's draw that line. And I just realized, because my brain's not working, I just realized that I did a negative slope. So maybe some of you caught me in that, and if you did, I'm so proud of you. I did a negative slope of 5 halves. I'm so sorry. So erase, or if you have a pen, cross it out. I'm sorry about that. So we still have a y-intercept of 5, but we want to go down 5 and left 2 to have a positive slope. I apologize. you'll realize that I'm far from perfect, but I knew something was wrong because that wouldn't reflect each other. So anyhow, so let's draw a line correctly this time. So they both have a positive slope, and when you reflect it over this blue line in the middle of the y equals x, then it will reflect on one another, which is what inverses will do. So that is the correct inverse graph of this 5/2 x plus 5. So now the substitute is going to pass out your assignment, and I'm going to do one of those with you. Okay, well, hopefully you have your assignment. You had your name on it. Remember, this is not due until Thursday. And so if you need help on this, ask a friend, ask Mrs. Blake until I return, and I will for sure help any of you that need help. But let's look at question number 2. So question number 2 looks like this: 2 over x plus 2, and then plus 2 outside of the fraction. So remember, first thing you want to do is replace y, or f of x with y. And if you want to just cross it out and write y right here to save you some space on your paper, that's more than fine. Because then we have to rewrite it anyways when we switch x and y. So that's the next step. Let's switch x and y. So we'll have x equals 2 over y plus 2, and then plus 2 outside. And then we want to solve for y. So y is in this fraction right here, and we need to first get rid of this plus 2 over here. So it's the opposite of adding 2, so we're going to subtract 2 to each side, and that will zero out. And then on the left side here, we'll have x minus 2 equals 2 over y plus 2. Okay, and I don't have an example like this, which is why I picked this problem specifically. But what happens is we're solving for y, and it's in the denominator of this fraction. So let me show you the long way, and then I'll show you the shortcut that you can do after this. But I want to show you why it works. So I can't just multiply by y to each side. I have to keep y plus 2 together because it's a sum right now. So I'm actually going to multiply both sides by the sum of y plus 2. So I'm going to multiply by y plus 2. And then what will happen is when you multiply by y plus 2, that's y plus 2 over 1, so these will cross out. And that's why that works nicely, because it will get out of the denominator part of the fraction. So then, and you're probably running out of room, but you have to go to the right side. So then we'll have y plus 2 times x minus 2 equals the 2. And then, since we're still solving for y, we need to get rid of this. So the opposite of timesing by this x minus 2 is we can divide each side by that x minus 2. So we're going to divide each side by x minus 2, and that will get rid of that. And now we have y plus 2 equals 2 over x minus 2. So I want you to look at this. Let me highlight what I'm showing you here. So what we had is we had this equation. We had x minus 2 equals 2 over y plus 2. And now we have this equation, y plus 2 equals 2 over x minus 2. So what is the difference between these two? Well, hopefully you can see that these quantities just swapped places. So these will just end up switching places. And that is the shortcut if you have another problem like this, which you will on this assignment. So whenever the variable you're solving for is in the denominator, and you have this fraction by itself, notice this fraction I have is completely by itself, because I had already subtracted this 2. When it is by itself, then you can switch with what's with the variable you're solving for and what's on the other side of the equation. So you can swap those 2 quantities. Okay, so now, going back to our problem, because we're not quite finished, is, I can find my color I was using. So now we're not quite solved for y, we still have this plus 2 next to it. So we just want a minus 2 to each side of the equation, okay? And when we subtract 2, that subtract 2 does not go with the fraction. It's out of the fraction. So it will be 2 over x minus 2 minus 2. And if you remember the very last step, instead of writing y, just save yourself some space and write f inverse of x equals 2 over x minus 2 minus the 2. And that is the inverse of the original problem. And the answers are on the back for you to check to make sure that you're solving it correctly. And there are quite a few problems that are similar to this one. So please work with one another, help each other figure it out, and I will see you soon.